Timeless concepts from Physics Helpline. In this video tutorial, we will discuss a multiple choice question on the deflection of a charged particle moving inside a uniform magnetic field. The question is as follows. Read the question carefully. The situation is shown in the figure. A uniform magnetic field B exists in a region of space as shown in the figure. It acts in a direction perpendicular to the plane of the figure. The width of the magnetic field region is equal to d. A proton of mass m and charge q is accelerated by a potential difference V, such that initially it is moving along Pm. When it enters the magnetic field region here, it moves through the magnetic field region in a circular path and moves out of it along the path QR. Therefore, the deflection produced in its path from along Pm to along QR, the angle between them is theta. If the deflection is theta, then we are required to find the value of sine theta. Now for the answer. When a particle of charge q is accelerated through a potential difference V, then the kinetic energy gained is equal to q into V. If m is the mass of the charged particle and v be its final speed, then its kinetic energy half mv square is equal to qv, which gives v is equal to root over 2qv by m. Again, when the charged particle is moving inside a uniform magnetic field acting perpendicular to it, it will be moving in a circular path. Let the radius of the circular path is equal to r. Then the necessary centripetal force is mv square by r. This has got to be provided by the magnetic force qvb. Q is the charge of the particle, v is its speed, and b is the magnetic field. From this we get r is equal to mv by qv. Now we will put the value of v from this equation. Therefore r is equal to m by qb. M by qb we have put, then for v we have got multiplied by root over 2qv by m. Now 1 by b remains outside, and we can see that m divided by root m becomes root m in the numerator, and root q divided by q becomes root q in the denominator. Therefore, r is equal to 1 by b into root over 2bm by q. Now, for the value of sine theta. It is the angle between QR and PM is equal to theta. Now, OQ is perpendicular to QR and ON is perpendicular to PM. Therefore, the angle between ON and OQ is also equal to theta. OQ is the radius of the circular path of the proton, which is equal to r, and NQ is nothing but the width of the magnetic field d. Therefore, sine theta is equal to d by r. That is what we have written here. Sine theta is equal to d by r, which is equal to d into r. R is nothing but d by r, that is 1 by r. We will take the reciprocal of this. So r is equal to 1 by b root over 2 bm by q. Therefore 1 by r will be b into root over q by 2 bm. That is what we have written here. D into b into root over q by 2 bm. Rearranging, we get sine theta is equal to bd into root over Q by 2Vm, which is the answer to the question. Therefore, the correct option is B. This completes the answer to the question. Thanks for watching. If the video is helpful, then please like, share and subscribe.